Okay, now, do we remember this symbol from last week? Yes, we have long S problems, right? Because it's a long S. Okay? Yeah. So, but this means we're taking the integral, we're going the opposite of taking the derivative. Okay? We were finding the area under the curve by finding rectangles, left and right-hand rectangles and whatnot, and adding them up. Well, if we have a figure like we do down here, we don't have to worry about estimating. Since these are figures we know how to find the area of, we can actually find the exact area of them. You with me on that? So we learned about left and right-hand rectangles and estimating for the concept part of that. And then we're going to use geometric figures so we can understand some of the properties of integrals, and then we'll kind of put all that stuff together. So we're not estimating today. We're not doing left and right-hand rectangles and trapezoids. And, well, we might have rectangles and trapezoids, but just because they naturally appear this way. And we have all of these different integrals. So we want to make sure that we understand how to read them because we looked at that very, very little, right? What this means is, now this is the graph of f of x, okay? They have given us some values for when you integrate g of x. We don't have to go find that. We don't have the graph. They just gave us, this is what it is. So if I want to take the integral from -6 to -1 of g of x, or the area under the curve, the accumulation from -6 to 1, these are x values, so going from -6 to 1, or -1 rather, when I integrate that, my answer is -1. So it's giving me the question and the answer so I can use them in some of these down here. Okay, and then we're actually going to find some of these. Now, words are important. We should read our instructions and the little things that they tell us because this says that we have a quarter circle. When you look at this, does this look like a quarter circle? No, because it looks squished, right? But it's because the scale is not, it's not a square scale, all right? But if you look at this, we have 1, 2, 3 here, and 1, 2, 3 here. So the radius is 3. It's just that it's sort of squished down, kind of like a calculator screen would be, right? And 5 line segments, so there's no question that the only thing that's curvy is that part of the circle, and we're going to find the definite integrals, okay? So we're going to go from, if I want the integral from 0 to 1 of f of x dx, well, this is f of x, right? That means what I have here is I have, this is the derivative, right? So I'm going even though it doesn't say f prime, this is still the derivative of something, and I want to go the opposite way, so I want to find the area under the curve from 0 to 1. So from 0 to 1 is right here. This is what I'm finding the area of. I'm not going to shade it in because I'm going to write in it, but this is a triangle. We know how to find the area of a triangle, right? Okay, what's the base length of the triangle? 1, and then the height is 4. So 1 times 4, you take half of it, you get 2. So I'm just going to write a little 2 in here because then if I need that part again to add to something else, I already have it. I don't have to figure it out every time. Okay, so my answer here is 2. Okay, does that make sense to you? So you could go ahead and chop up and just find the area of each part. You're just finding the area between the curve, which I know some of these are straight line segments. We still consider it a curve. Between the curve and the x-axis, going from 0 to 1. My answer is 2 there. Okay, does that make sense? All right, so I want you to do number 2. And then I'm going to show you what else you're going to do with this. You can talk amongst yourselves. Okay, so I want the integral from 1 to 4, so from 1 to 2, 3, 4 of f of x dx. So that means I'm going from here to here, and I want this area, okay, going from 1 to 4. So the base is 1, 2, 3. The height is what? 4. So the area is 12. Okay, makes sense? Then, so you're going to go through these together, and then some different things are going to happen, and you're going to have to figure out what that might mean. This is going to be one of those where I release you a little bit without a whole bunch of knowledge for you to kind of play around with things. And here's how you're going to know if you're right or wrong. Well, maybe, what? Okay. In Schoology, one of the things the link that is in there, because I just put it in there, that's what made me realize I didn't put the rest of the stuff in there. You have this link of properties of integrals. You're going to click on that. It's going to give you a redirect, and you can say continue because it's coming from Schoology. And then it's going to ask you to make a copy of the document, so you just click make a copy. Make a copy. Okay. Then I should have brought my keyboard up here. So what is the answer we got for number 1? 2. Okay, so I'm going to type in a 2. And it turns green. Okay. Now, what did we get for number 2? 12. So let's say that we got 14 because we added that 2 to it because we weren't paying attention or whatever. Get 14, it's going to turn red and say, nope, that's the wrong answer. Okay? So if I put in the correct answer, which is 12, then I'm good. Okay? The next one we're going to look at so that we know how to type things in correctly is, I think it's number 11, but let me double check that I'm looking at the right thing. Yes. So let's jump to number 11. Okay? We're on number 11. So I'm taking the integral from -6, so 1, 2, 3, -6 to -3. So that means I need this area right here of this, and we know it's a quarter circle. What's the radius? 3. Okay, how do you find the area of a circle? Pi r squared. So what's the area of the entire circle? 9 pi. Pi r squared, so it's 9 pi. Yes, it's 9 pi. This is a fourth of it, so this would be 9 pi fourths, right? Okay. Now, because we're using the sheets to do this, and there's only one way that it's actually going to take it correctly when you type it in. So when we go back over here, which is probably not going to let me now, but I got to go back to my keyboard anyway. You're going to have to type it in like this. Let me get that spreadsheet back up. There we go. So we go to number 11, and instead of doing 9 pi fourths, you're going to have to do 9 fourths like that times pi, except spell it right. There you go. And then it'll turn green, okay? But that's the only way it's going to take it. If you have to add something to it, I'm going to show you, it's going to be wrong because this is not the answer. But if, let's say it was 9 pi plus 5 because I had to add something else to it, then it would be plus 5 like that, all together with no spaces, okay? And always put the pi part first and the constant part second. Obviously, that's the wrong answer because I just told you it was, but that's how you're going to be able to check yourself, okay? The last thing, or I guess I can leave the right answer in there. The last thing is, when you do this, go down the columns. Don't go across like this because they're set up to get kind of, the difficulty increases a little bit as you go and as you try and figure some things out. And if you go across, then you're going to be jumping all over the place and it's going to be difficult for you. Okay? Does that make sense? All right, so get your devices out, get into Schoology, and click on that thing so you can check all of your answers.